So this is a low fidelity prototype of the top section of my modern repeating crossbow. Basically what that means is it's supposed to look scabby, at least for now. I want to dial in all of the mechanical features completely before I worry about the aesthetics. So for features, we have a modern reverse draw setup with a riser system. We have doubled limb springs on either side. And then this riser has this TPU padded clamp in the middle, which dampens vibration, but also improves the bow action of the limb spring. So instead of the limb just kind of being pulled over like a lever, the clamp kind of pushes the middle out as the ends get pulled in, because this limb receptacle swivels. So even though the limb is secured here and here, when this bends, this moves as well. This set of limb springs is printed in PLA. But the great thing about engineering limb springs out of PLA, despite it being not nearly as strong as carbon fiber nylon, is the design improvements you make while you're prototyping with PLA will translate to when you reprint them out of carbon fiber nylon. So it makes sense to dial in the limb springs out of cheap material first and then switch to carbon fiber nylon. The key thing to think about with 3D printed limb springs is you want the stiffness of the belly to be balanced with the stiffness of the face, so neither of them overpower each other too much and cause stretching. The curvature that you see on the face and the belly of the limb springs, this roundedness, what this does is it increases rigidity without sacrificing strength. We still have great strength along the X and Y axis, but when you have a layer stack that's inclined, the offset of the outlines increases rigidity. The cam pulleys have twinned cable cams for perfectly symmetrical tension. This is what it looks like. It's just a flat strip. Normally this wouldn't really work because it's so flimsy and bendy, but with the way that the enclosed runway is designed, there's very little clearance, and so that actually acts as a constraint that protects it from that vulnerability. Hopefully it works out, because if it does, it should reduce maintenance, and it's, you know, a lot more user-friendly to tie a granny knot to a fucking tab than it is to tie a traditional serving, which I'm pretty sure requires you to be like a level 100 basket weaver or some shit. And then to prevent the sled from exploding at the finish line, I have these TPU shock absorbers, which actually seem to work fairly well. And then last but not least are the cable tensioners. This is my innovation to the world of crossbow technology, which I hope catches on. But basically, it's the same kind of tightening mechanism you have on a guitar. It's always drives, and you just turn it, and it has so much torque that it can't be back driven, even with all of this tension acting on it. Just so you can. Here's a better view of that in action. See, another great thing about the cam tensioners is I don't need a bow rack. I can just loosen the tension all the way, and then it's very easy to work with. And then you just you burn goobers into the ends, and then you just shove them into these little ports. It's hard to do this with one hand. Shove it into that port, wrap around like that. This thing just keeps falling out. The reason that shot went so much higher is because I removed this ghetto support by accident, so now the crossbow was tilting upward. Holy shit. Okay. It's not the most rigid support, but hopefully we can get some accurate shots now. Hell yeah. That's fucking accuracy. That one totally hit the other bolt. Totally hit it. Oh, what? Oh, I broke the sled. Shit. Oh, wow. Okay, now I see why the sled broke. The bolt fell through the magazine opening and then jammed against the bench vise. Yeah, so I think I'll just hold off on brake testing the limbs for now and print some backup parts, and then I think next weekend we'll do some brake tests, see what this thing can actually handle. I decided not to include the recording of me getting all pissed off, but I couldn't release the serving, and taking a closer look, I suspect that once this was under tension, like enough tension, it was like too hard to get it to go past. And so what I need to do is make this shape more robust. Maybe go with a bigger axle. Yeah, basically just have to make this whole mechanism more robust. Give it some extra range of motion so that it can for sure release